Good morning again. So this presentation is going to focus on an auxiliary research question of mine that is independent of my thesis, and that is modeling aoudad population growth in Texas in the face of uncertainty. All right, to get us started, aoudad populations are enjoying a prolonged population and range expansion in Texas. There are a series of factors contributing to this expansion, many of which stem from their generalist nature. As a generalist, aoudad display a high degree of dietary plasticity in that they can operate as a browser or grazer depending on the resources offered within their environment. This enables a high degree of adaptability among aoudad in novel landscapes. This makes them a very effective colonizer of invaded ecosystems. Like I discussed in my prior presentation, the aoudad's expansion into the Texas Trans-Pecos has stimulated concern regarding potential niche overlap and competition with desert bighorn sheep and mule deer. If niche overlap and competition are present, anecdotal information suggests aoudad would be the superior competitor in this fight for resources. This species is particularly gregarious. They're aggressive and they boast a large body mass. These factors offer them an increased defense from predation and a stronger presence in competitive battlegrounds. Given the austere conditions in which they've adapted to in northern Africa, anecdote suggests that aoudad are more resilient to poor environmental conditions such as drought, resource scarcity, and predator presence. The species also appears to be robust to disease and parasites in North America that are detrimental to desert bighorn and mule deer populations. This would offer aoudad a decrease in natural mortality rates and therefore an increase in population growth rates in Texas. There is also available literature in aoudad populations across the globe that suggests that the species possesses a suite of reproductive characteristics that would enable them to far outperform desert bighorn sheep and mule deer from a population growth perspective. To elaborate on these superior reproductive characteristics, data collected on invading aoudad in Spain suggests the species can be more likely to have twins than desert bighorn. They are capable of breeding more than once per year, unlike either of our two native counterparts, and that ewes can become reproductively viable at as early as 9 months old. So, comparing aoudad to just desert bighorn, they can have twice as many lambs at a time, can breed twice as often in a given year, and they become reproductively mature in half the time. However, this data represents Spanish aoudad. We do not know if these characteristics are present on Texas landscapes. There is a significant gap in our data regarding the ecological characteristics of aoudad invasions across Texas. Given these superior reproductive characteristics I outlined in the previous slide, if there is niche overlap present between aoudad, desert bighorn sheep, and mule deer, and if they are competing for shared resources, then these superior reproductive characteristics would offer aoudad a significant numerical advantage on competitive battlegrounds. So this begs the question, do Trans-Pecos aoudad possess these survival and reproductive characteristics? If so, how fast can we expect populations to grow? And how does that population growth compare to that of desert bighorn sheep and mule deer? These outline the broad objectives of this project, and that is specifically to compare desert bighorn sheep and mule deer to aoudad population growth, given aoudad possess a suite of these potential reproductive characteristics that we have found in aoudad in other parts of the world. Given the uncertainty regarding aoudad reproductive characteristics in Texas, we ran simulation models using scenarios in which Texas aoudad possess all or a combination of these reproductive characteristics. We then looked at how these combination of characteristics influence their population growth in comparison to desert bighorn sheep and mule deer. These scenarios included all or some of the following characteristics, just to go over them again: that aoudad possess a higher survival, that aoudad are more likely to twin, that they are capable of reproducing twice a year, and that they become sexually mature after their first year. This is a conceptualization of the model I used to perform these simulations. The animation you see here represents the flow of aoudad through these sex and age classes throughout their life. So it does consider age and sex structure influences on population growth. It also considers stochasticity and survival parameters when modeling mortality amongst these individuals. When we run this model to simulate population growth between each species, we start with 50 individuals and then track that population growth under these varying scenarios that I mentioned in the previous slide over the course of 10 years. To get into some results, this first plot I'm showing you represents a scenario in which Aoudad possess none of these reproductive characteristics and that they only possess slightly higher survival rates. We can see that, generally speaking, the population sizes of these simulated Aoudad after 10 years of growth are fairly comparable to that of mule deer. However, even under this scenario, Aoudad demonstrate a growth rate that is double that of Bighorn. I am now going to show you how population growth of Aoudad would compare to desert bighorn and mule deer under the worst case scenario, and that is in which Aoudad are capable of breeding twice per year and they're able to twin proportionally more often, and that they become reproductively viable after the first year, and that they have a higher survival rate. So this trend represents reproductive characteristics that we know Aoudad are capable of possessing. Under this worst case scenario, Aoudad exhibit population growth rates over 600% that of desert bighorn sheep, where bighorn grew to a population of roughly 200 individuals over the course of 10 years. Aoudad grew to nearly 3,000. So here is every scenario plotted out on a graph, and there are a couple key takeaways that we can pull from this. The first being that all Aoudad population growth scenarios resulted in faster growth rates than desert bighorn. Second, notice there is this hard separation in these growth simulations. This represents the break between scenarios that do and do not include Aoudad reproducing twice per year. This indicates that Aoudad population growth is most sensitive to whether this characteristic is present, suggesting that if we were to pursue research questions regarding these characteristics, we should look for evidence of 2 reproductive episodes per year first. Now, this model makes a few very large assumptions about reality that we know are false. The first being, these models do not include the effects of carrying capacity on growth rates. We know that as populations approach carrying capacity, there are fewer resources available per individual, therefore population growth rates would start to decrease. That's not accounted for in this model. However, given that it is not necessarily the discrepancies in total population growth that we are analyzing using this model, it is rather discrepancies in growth rates. Now, assuming that approaching carrying capacity affects these species relatively equally, including the effects of carrying capacity would not change our scope of inference, therefore substantiating our technique to maintain model simplicity here. Also, this model does not include any empirical data regarding Aoudad survival. Anecdotal evidence suggests Aoudad are particularly robust to North American predators and disease. Therefore, data regarding these characteristics would be essential in developing a more representative model of Aoudad population growth in Texas. This model does serve as a good starting point for initial thoughts regarding Aoudad management, however. After a few months of sitting on these growth models, I realized I can include a model parameter that represents Aoudad control efforts and analyze its effect on Aoudad population growth. I was curious, under that worst case scenario, how many Aoudad would we need to harvest in a given year to keep Aoudad populations from growing? So I simulated varying management quotas from 10 to 90% harvest of ewes per year, and here are my results. I found that under this worst case scenario, to keep that Aoudad population from growing, you would need to harvest 80% of the ewes in a given year. So to put this into perspective, if you had 1,000 Aoudad, 500 of them were ewes, you would need to harvest 400 of those ewes in a given year to have 1,000 Aoudad next year. This according to these simulations. Here are the simulations using each management quota. There does appear to be some degree of diminishing returns once you approach management quotas north of 60%. These results would suggest that management efforts involving the harvest of at least 60% of Aoudad ewes in a given year would keep Aoudad population growth rates below that of desert bighorn and mule deer. We are actively working to improve this model. We're preparing a study to develop data regarding Aoudad reproductive characteristics in Texas. This will be useful in replacing Spanish data used in this model with data collected in Texas. We will specifically be looking to quantify Aoudad fecundity rates as well as the seasonal reproductive behavior. That is, identify how many lambs they're having and how many times per year they're having them. Anyway, that's what you can look forward to in the future. Again, I will not be available for questions following the conclusion of this presentation. However, my advisors, Dr. French and Gonzalez, will be available to field any questions that you may have. Thank you.